the other guy that usually does that is fired. That was amazing. Welcome, wow, this is a massive audience, to Austin JavaScript for August. Sad panda over here. How many first-timers in the room? The whole room? Google closure.
How many people have been here before?
That's true. How many people have been here before? So yeah, next month you guys won't be here. It's cool. I understand. I guess this Google closure thing is a pretty big deal, right? So thanks for coming out. I'll give you guys a kind of a rundown of what we do here. We start off, obviously, looks like you guys have destroyed the pizza. Well done. Let's work on the keg next. There are bathrooms right around the corner. There's the women's room is first door on the right, men's room, third door on the right. Don't go over there. That's all I'm going to say. Frog does a big favor for us to let us use their space, so let's respect it. We're going to do the talk first. We have David from Indeed going to give a talk on Google Closure Tools, and then we'll have a bio break in between for about 5-10 minutes. And then we do the ever-famous Andrew DuPont branded note card questions and or jokes and or heckles of yours truly.
I didn't get my permission for that.
Don't worry, check in the mail.
It was implied.
Yeah. No, seriously, so like we write questions, JavaScript related, whatever, web development, mobile, doesn't matter. Anything that could be answered by this ridiculously talented and smart engineering group that we have here tonight. Also, we'd like to thank our sponsors, the beer, the pizza, the space, all the free t-shirts and koozies, and I mean, where else do you go to get this much free stuff? They're handing out jobs too. I mean, they should run for president, seriously. So, Luna Data Solutions. Last month they were also a sponsor, and I even mispronounced their name, and they came back again.
Wow.
So I'd like to give them an extra special thanks. Luna Data Solutions. Christina's here. She's going to give a brief intro about what their company does and some opportunities there. So, take it away.
Hi guys, can y'all hear me? Yes. My name is Christina. I'm with Luna Data Solutions. We are a high-tech recruiting firm based here in Austin, Texas. We've been in Austin for about 10 years, and we work with the public sector of the government, state agencies, and also private sector companies to help with their high-tech hiring needs. And I have a couple of JavaScript jobs I'm looking to hire. And so I have a senior level UI engineer role, and then also kind of a mid-level front-end developer role, all JavaScript, HTML, CSS. The senior one, we're looking for someone with some Ruby experience if they have it. So, if you're on the market, I brought my team with me. We're wearing the white t-shirts, and so maybe if you want to discreetly come talk to us during the break, or send us an email or whatever. If you got a koozie, we'll leave some cards around. You can just pick one up and email us later. But I'm Christina with Luna Data Solutions.
Thank you. And by the way, we do go to the Ginger Man after this. And we keep drinking beer, and that sponsorship is also provided by the Daily Dot this month, so thank you very much. Zach is here from the Daily Dot, and he's going to explain a little bit about what they do and the opportunities that they have as well.
All right. Hello, everyone. So, to give you guys a quick background on the Daily Dot. We've all, grown up, at least seen our parents read newspapers. I'm sure there's some people young enough that they haven't ever actually read a newspaper. However, that whole world's changing, and people are starting to live a whole large part of their lives online. So how come people don't report news on those communities? So we are the hometown newspaper of the World Wide Web. We report on all the online communities and all the happenings online as if it were real life happening down the street. So we've got a whole bunch of reporters that are actually scattered throughout the US that cover beats like Reddit, Pinterest, and also almost any other community that you can imagine. Some rather esoteric, like the Brony communities. However, we've been around for about a year. We're coming up on our anniversary on the 24th, which is going to be this Friday. Yes, and we've just hit 1 million users. We're about to break even. We actually double our audience every single quarter. We've been doing that for the last 4 quarters, and we plan to keep doing the same sort of thing. However, with that, we're actually going to be growing our development team. Right now, we're 4, currently spread. I'm bringing most of the team, moving them here to Austin, and we're looking to grow the team in Austin. We are looking for a lead UI developer. We're going to actually be moving to Google Closure. So if you haven't worked with it, you think you want to work with it, definitely come talk to me. Also, if you want to do awesome adaptive design stuff, if you want to work with new HTML, almost really anything new, we're more than happy to provide you the resources to go and do that. We're moving to a new office above Perla's, which down on South Congress, so that's also a pretty cool benefit. So come talk to me either here or later. Also, make sure you grab a shirt. I don't know how many I've got left. There's just mediums and larges. Also, we have our once per year commemorative South by Southwest print edition. It's the only time you will ever see it in print. So in like 10 years, this is going to be like a fossil. It will be worth millions. And thank you guys.
All right, thank you. All right, so everyone's boozed up, pizzaed up. Oh, there is soft drinks too if you guys don't drink. I'm not like pressuring you. So David Tulig is going to talk about Google Closure Tools. So take it away.
Great, thanks. Okay, well, like Joe said, I'm going to be covering the Google Closure Tools. And I'm not going to go into big detail kind of about how you actually set this up and how you would actually get this started on your machine, but more give a high-level overview of why Google made the decisions that they did when they were putting the tools together, and give some of the reasoning behind them, the 3 different tools that we're going to end up talking about. And then we'll go and talk a bit about resume search, and we'll go over how we were able to leverage the Google tools to build resume instant search and the benefits that we saw from it. So real quick, I just want to introduce myself. I'm David. I'm a software engineer at Indeed.com, and I primarily focus on the resume team. I've been at Indeed just over 3 years now, and I've been working with the resume team since it was started a year and a half ago. When we started that team, we had a unique opportunity in that we didn't have any technology. We had nothing to go off of, so we had a chance to start from scratch. Given that, we explored a couple of different technologies for how we were going to build our front end. We had a little bit of jQuery around the office, and we had done a lot of our work in just raw JavaScript. But Google had recently open sourced their Closure toolkit, and we wanted to see if what they had released would be helpful to us. And after evaluating for a bit, we saw that, yes, there are some pretty nice benefits of using it, especially at a growing organization where we're not going to be just using JavaScript on a single page. We need to use it throughout the whole company. And it would be great to share the code that we write. So we ended up going with Closure. And so we're going to take this step today. So let's go ahead and look at what an app used to be like when we wanted to get started from scratch. We're going to go with a jQuery app. Something very familiar with everyone else. Let's say we're going to build a photo sharing app. So first, we go ahead and we put jQuery on the page. From there, being a photo sharing app, we're going to go ahead and add a lightbox. So nice little effect you can have on galleries, show off all these images. From there, we want to add, let's say, a table sorting plugin so that we can do some table sorting of some of the stats maybe about your photos. At that point, we realize that we want to do, with photo uploading, we want to allow users to add a date of when the photo was taken, or just some other metadata about the photo. And so we want to add some validation. So we find a nice validation library that we like, but it requires a date library if we want to actually do date validation, which is fine, so we can bring in the date library and as well as the validation library. And at this point, we're starting to see we're bringing in quite a lot of different components, and actually we'll stop there because we're running out of room on the slide, and actually start writing our application. But the first problem that we can kind of run across here is that we manage all of these dependencies all by ourselves. So we knew with a lot of these plugins, we were going to need jQuery. And for our app itself, we needed jQuery. But when it came to the validation, it was a bit less clear what was actually required. We had to read the documentation and go through the source code to understand that we needed to include the date library as well. So the next thing that we kind of run across is the fact that we didn't really have any good namespacing here. With jQuery, it's pretty straightforward. We're going to have the dollar symbol, and that's going to be global namespace and what everything's going to be extending off of. But with the validation library and the date library, that's relatively an unknown. It could be using just pure functions on the window, or it could be using maybe the V as its main namespace. And then moving on from there, it isn't very clear kind of style that we're going to be working with. The validation library is going to have a very different style from the jQuery plugins. Even jQuery plugins themselves have very different styles. So if you're working with one, and then you move to another, you might have to relearn kind of how the author set things up. So we continue moving through our application, and we want to start doing some templating. So here's kind of a pretty old-style way of actually building templates. If we wanted to add a table to our page, we could do it with string concatenation. But you instantly see a couple of issues with this. For one, you're mixing a lot of your logic with your presentation. And we all know from working with PHP a number of years ago, that's not the way to do it anymore. And so with JavaScript, it's come along a bit of a way. You do now have like jQuery templates, and there's a lot of other templating systems that are available to you. But one issue you still run across with this is that if you're doing items on the server side, you have to rewrite those templates, or you have to forego doing those templates on the server and take roughly fine. And on the server, you might be using something like Django, or JSP, or Ruby. And so it's a vastly different technology than what you actually end up using on the front end. And so your choices are then either to write your templates twice. You can write them on the back end, and then write them again on the front end in a pretty different language. Or you just skip doing the back end altogether, and you do all of your templates on the front end. And the reason, though, that you do really want that, or at least we found, that you want to have templates both on the server and on the client, is to get some speed benefits and some SEO benefits. And we're going to see those a bit more when we actually look at resume search and how it's leveraging the Clojure templates in order to solve some of those problems. So let's go ahead and decide we're ready to build our application. Got a little stretch here. But being smart developers, we're going to go ahead and combine all those files into a single JS file. We're not just going to load all 5. That wouldn't be very smart. We're also going to compress it. Let's say we use the YUI compressor. And we get it down a bit more. That's 133. Can't read letter over letter. And then finally, we're going to end up gzipping it. And with gzipping it, we get it down to a much more reasonable 45K. So we're going to push that number aside for a little while, and we're going to revisit it as we get towards the end of the presentation. So just kind of a quick recap over some of the problems that we're looking to solve by working with the Clojure library. The first being dependency management. We don't want to have to think about what our dependencies are. We don't want to have to know that we need jQuery for this script, or we don't want to know that we need a date library to make the validation work. The next thing is the namespacing. We want to have kind of consistent style, consistent way of working with the different libraries. And this goes for code style as well. The code style just between those plugins that we were looking at there is vastly different from each other. And then if you have this at your organization, you have different styles within different teams. And so if you're ever to move between teams, you're going to have a harder time jumping right in because you have to learn how they wrote their JavaScript. And then finally, you have to make a choice with your templates. You can write them twice, you can choose to do it all on the client, or you can choose to do it all on the server. So let's go ahead and jump into using Clojure. So I want to start with the Clojure templates and kind of cover a little bit about what the Clojure templates provide that a number of other template libraries out there don't currently have. The first one is that it's strictly presentation only. And the Clojure templates actually really tie your hands, so you cannot do that with logic. So it comes with your basic control structures. You'll have your if, your for loops, as well as a couple utilities like min, max, length, And you can implement things like pagination. It gives you enough power to do that, but not much more from there. So it really does force you to make it presentation only. So here's a quick example of what a template would look like. If you work with Django, it's a very similar style of syntax. A couple of quick things to point out here is the namespacing at the very top. And we're going to see this a bit more when we get to the Clojure library. But you get a little hint that Clojure is going to start doing some things with namespaces. And you see they're a little bit long, it's kind of Java-esque, but we'll see how that comes into play as we start talking about the way the library is going to manage dependencies. So with that, let's go ahead and jump into the library. So the first thing that I want to talk about with the library is the same thing that we were talking as a major problem with when we weren't using the frameworks, and that's with dependency management. So Clojure's way of doing this is giving you utilities, provide and require, that allows you to specify what modules are within each file. So in the Clojure library, you don't want to keep all your files in one large JS file. You end up breaking it up into a lot of small files. And you use these provide statements to describe what is actually in all of these small files. And then you can see another example here of using require. And that's how you actually ask for other pieces of the library. So here we're asking for a lot of the Google pieces, so the DOM and the events. But we don't actually care what events requires. We don't care what DOM requires. All those transitive dependencies are going to be handled by Clojure's dependency management system. And this makes it really nice because you don't have to keep track of any of your dependencies. The library comes with scripts that will actually do all the scanning for you. So they'll scan all your JS files, your whole project, and figure out exactly what your dependency tree looks like. And so when you're ready to use it, you just include that dependency tree, and Google's going to start bringing in all the dependencies as they're needed. So the next thing I want to go over in the library is just kind of show you a little sample of kind of the style that Google kind of suggests when you're working with it. It's a little bit more verbose than you might usually expect when working in JavaScript. And so it does come out a little bit Java-ish. But it has a good number of benefits with this. By having very long and descriptive function names, you have a complete understanding of what is actually going on here. So you understand that goo.format, that email address, is valid address spec. It's very clear what that function is going to be doing, and that's going to be validating an email address. Now, unfortunately, there's nothing like an import statement in Java where you can just import the email address package and get down to just is valid address spec. But with a lot of modern text editors and IDEs, I found that this typically isn't really a problem. You get a lot of code completion. And so having these longer descriptive names is extremely useful then for new developers coming in looking over the code, because it's easily understandable on what is actually going on. And we'll see a little bit later about how these longer nesting objects aren't actually going to be affecting performance either. Right now, we are going a bit deep. We're at least 3 levels here. But with the compiler, it's actually going to take it down to just a.b at the end. And so we aren't going to be doing these really deep lookups. The final thing I want to point out here is the JavaScript documentation. So a lot of times, you use the JavaScript doc just for documentation. But here you'll notice that after the add param is a type definition. And this again is going to come into play a bit more with the compiler, where we can start annotating a lot more of our code with what type we're expecting. And then the compiler is actually going to be able to do some simple checks for us. So the next thing with the library is just the extensive set of libraries that it comes with. So it has your basics, it has DOM, and then it has events, as well as things like positioning that aren't as common, although nowadays I know jQuery can make it standard. But then there's things like storage, utilities for working with local storage, which is kind of helpful, and then a full UI toolkit. And this is just a couple of them. There's a ton more, and even on the slide are only the ones that would fit. But it has other utilities like an editor. You have a full-fledged editor, internationalization assistance, dealing with locales and dates. And while this isn't as big of an advantage as it used to be, a lot of frameworks now do come with a very extensive set of libraries. It's nice because they're all in that same format that we were just looking at. They all have the provide, the requires, and they all follow the same kind of namespaced way of doing things, as well as just a general style guideline of how they're written. So the last thing I want to talk about as far as the library is concerned is the unit testing framework. So as we've been building larger and larger client-side web applications, we've started to realize we need to start following a lot more software engineering principles, one of those being unit testing. And so with Clojure, it makes it extremely easy to get started with unit tests. You don't have to worry about setting much up yourself. It plugs into the existing dependency framework so that you can just bring in the JS unit framework and your code and just start writing your tests. In addition to that, it also comes with some nice test runners. So here's an example of one that actually works really well on headless systems. We've done this on Phantom.js and with Selenium. And then if you're doing this, it also has a full suite runner, so you can run all of your tests all at once. So you can asking which ones are failing, and a bit of timing information if your tests are time sensitive. So a quick recap on that. With the templates, one of the big deals is that you do separate your templates completely from your JavaScript. You actually cannot put JavaScript in your templates. You also get you get managed dependencies with the Clojure library. You don't have to worry about keeping track of it. The scripts will do it for you. And then you have an extensive set of libraries. Although, like I said, it's not as big of a deal as it used to be. But it's still nice to have them all the same style. So as you're looking through all the code, you can get a really good understanding of what it's doing, because you don't have to learn a new style when you go file to file. And also then, you get a unit testing framework. So you can write your tests really easily, and you don't have to worry about setting it all up yourself. So the final piece of the Clojure toolset is the compiler. And I always like to start with this diagram, because it does a really good job of kind of tying together how all these components end up working together. So the compiler ends up taking all of your template code, all of your library code, and all of your application code all at once. And what this allows us to do is know everything. And so we're going to focus today on the advanced optimizations of the compiler. So if you've worked with the compiler before, you might know about there's the different modes that you can run it in. You can do a white space only, that'll just remove all the white space from your files. You can also do simple optimizations, that'll do simple variable renaming, but it does it safely, so only in the scopes where it's not going to mess with things. But with advanced optimizations, the compiler kind of takes things to a completely different level in the way that it does all of its renaming. So with renaming, like I kind of alluded to earlier, it ends up just renaming everything extremely aggressively. So it's going to take all of those long strings and just bring them down to A.B or G.H. Something that's just a single letter. And it's going to do other things like pull out all of your strings so that all your strings are assigned to variables, so you're not using long strings if you're repeating strings a lot. But one of the other big features that you get from it is the way it does dead code removal. So let's say we did bring in the DOM package, but we only actually ended up using the get elements by tag naming class function. It would be pretty useless to include the rest of this in the final code. So what the compiler will actually be able to do, because it knows everything that you're using, is it's going to get rid of all that code that you didn't actually use in the DOM package. So you don't have to worry about bringing in the DOM or the string or events and just using one piece out of each one. You can bring them all in, and it's only actually going to compile into the final file what you actually ended up using. So the last thing I want to go over with the compiler is its type checking. So as we saw earlier, you add annotations to all your functions. And in this case, we have a function with two parameters. The first one being a string, and the second one being an optional parameter that, but if it's present, should also be a string. What we ended up doing here was passing it a node as the second parameter. And it caught this at compile time. So it noticed by interpolating kind of all the other types and all of our source code, what we ended up passing to this function. And it complained to us, and it can then fail to build for us. And it will help with other things along these lines too. If you try to pass 3 arguments to this, it'll also complain. And it gives you just a little bit more of security that your code's actually going to work before you actually see it in the browser. And this is also very helpful because browsers like IE typically give very cryptic error messages. So you can solve some of those issues just by looking at the output of the compiler when it does its type checking. So the compiler is able to do what it does because it knows everything. It has all of your templates, the library, your application code, your summer entrance code, everything is pulled all into one. And then with the aggressive renaming and the dead code removal, it's really able to shrink down your final file. And then a nice added benefit is that it just has some type checking. So you get a little bit more safety before you actually go into runtime. So given those components, let's look at how we were able to leverage all those when we were building Resume Instance Search. So here's a quick demo if you're not familiar with it. Instance Search is kind of a show result as you type type of system. So you can see here, as we're typing Java developer, it's attempting to show us results. Same thing with JavaScript. And there's a couple of components here. You see the autocompleter up at the top, and we'll talk about that a little bit later. In addition to that, we've also added things like the preview, just kind of a nice little feature to to keep you on the page and make sure you don't leave the page until you're actually ready to do so. And then there's the refinements and other standard search tools. And as you see here, this isn't doing any page refreshes. It's just rewriting all of the results right there on the page. So with autocomplete, there's actually a couple of benefits of having it instead of just doing keystrokes and running a search. So as you noticed as you were typing, if we typed Java S, it's going to complete JavaScript for us. Well, what we end up doing with that then is we'll go ahead and get results for JavaScript before you even finish typing the word JavaScript. So when you're done, the results are actually already there for you. So it appears like it's extremely fast. And while it is actually still fast, you get an even more higher perceived performance out of Instance Search. So it's just a nice little trick that you get by using the autocomplete when you're doing a search like this. So let's break down Instant into the three components, and then we're going to kind of build it as if we were just going to naively jump into it without doing that much planning. So the main components that we're going to be working with here are the autocompleter, the instant, and instant here is just going to be the tool that renders the actual search results, as well as the refinements. And then the preview, which is what you saw on Hover when we showed a preview of the resume document. So to get started, we'll start with the autocomplete. We'll have the autocomplete start listening to keystrokes. It'll look at the text editor, or the text box, listen to keystrokes, and grab input. After it has some input, it's going to go and ask the server for some suggestions. So we'll call Ajax all the server to client communication. From there, once autocomplete has suggestions and has a result, it's going to need to communicate to instant. So autocomplete is going to call a function on instant that says, hey, here's a search query. You should go render some results for you. So autocomplete is going to ping instant. Instant's going to then go to the Ajax call, or the Ajax component, and go grab some results, and then render them on the page. Pretty straightforward. From here, though, we want to add preview, because it's a nice little way to give people who are using the site a chance to go see what they're looking at before they actually jump into it. But preview needs to know from instant what the results were so that it can go fetch from Ajax all the previews, because we want to do prefetching. We don't want to be looking up results on demand, because then people are going to see a little bit of a lag. When they hover over a resume, it'll take a while before the preview actually pops up. And then it needs to go grab the query from autocomplete, because it's going to want to do code highlighting, or it's going to want to do highlighting of the terms that you were searching for on a user's resume in the preview. And so at this point, we can start to see it becoming more of a web. Right now, everyone knows about everyone else on the page. And that's only going to actually end up being worse. What happens when we add the where autocomplete? We completely forgot about where. It's going to need to do the same thing as the what box. It's going to have to talk to instant, it's going to have to talk to preview, and Ajax. And so here we're starting to see a big web start forming where all these components are depending on each other. And so when that next new feature comes around, we're going to have an even bigger problem, because now it's going to want to talk to everyone. So the approach we took when building resume search was to go a bit more event-driven. And this is something, if you work with Node, you're probably pretty familiar with, and you like this style of using event-driven development rather than actually talking directly to different classes or components. So here's a high-level overview of what the architecture of Instance Search actually ends up looking like. All of the components are completely independent, and the only one that actually knows about the whole page is the cert controller. And so the way that this works then is whenever autocomplete has a change in its state, whenever it has some new text or someone clicks on a suggestion, it ends up firing an event. And the cert control is able to listen to that event. And if it's a new text event, it's going to say, okay, well, instant, you care about this new text event. You need to take this text and do something with it. So an instant can go and it'll do some of its own calls within its own hierarchy to render the results. And once Instant gets its results back, it can then fire an event itself saying, I have new results, here are all the IDs. And the server control will see that and go, oh, okay, well preview needs these IDs because preview needs to do some prefetching. And so server will then talk to preview and give it those IDs so preview can do what it wants to do. But at no point did any of these components actually know the issue existed. Autocomplete was working completely on its own. All it's doing is listening to text events and grabbing suggestions, showing those suggestions, and then firing events whenever it has new content. So what this is going to allow us to do is actually pull autocomplete out of the resume project. It doesn't have to be in just a resume, it doesn't have to be just on resume search. We can put it into a common library, and then of course leveraging the dependency system, use it across the company. So just to get a kind of a little bit more detail into how all this is working together, I wanted to go through just an autocompleter and kind of the life cycle of a couple of events. So in the text box, when you start typing, the input handler is going to grab that, and when it reaches the point, let's say you pause for maybe 100 milliseconds, it's going to fire an event that says, hey, I have new text, and it doesn't care who actually needs to know about it, but it's going to fire it up, and the autocompleter is going to grab that. Autocompleter is going to say, okay, well, with new text, I need suggestions. So it's going to go over to the AJAX and ask the AJAX for some suggestions. When the AJAX is back with some suggestions, it's going to fire an event itself, saying, hey, here's some new suggestions, it's for this, and then here they are. At this point, the autocompleter is going to do two things. The first thing is it's going to fire an event saying, I have new suggestions, here's the top one. And that's what's going to allow Instant to receive that event and then start pulling back results very quickly. At the same time, the autocompleter is going to be showing those suggestions to the user. So the suggestions get rendered, and the user clicks on one. Let's say they click on Java Developer. Again, another event is fired, and that goes up to the autocompleter, which then can again fire some events. It can fire the fact that, hey, we have some new text, it's Java Developer. And then the server control can decide who actually needs to know about this. And at the same time, we're actually going to set the text in the input to be Java Developer. So the user can see that, yes, we're actually working on this. So this ended up working really well for us. It allowed us to develop all these components in a lot of isolation. And as a result, we were also able to unit test all of these components in isolation. We didn't have to set up a full search page in order to write the tests. We were able to do it just on the components themselves. And even within those components, since they were broken up, we could test just the input handler and just check, is it firing the events we expect? So the next thing that we wanted to leverage was the closure templates. And so we have a couple of requirements whenever we are working on a web application. And those two requirements are speed, and then we want to make sure we can do good SEO. So to do both of those, what we really needed was the server to do the rendering. We need the server to render the initial request. So if you come in with a search already made, like with just query parameters, we need to perform it and give you results immediately. We can't wait for it to render a page, figure out what your URL fragment is, and then make another request to get the data to render it all with client-side templates. So we knew that we had the server-side requirement. We're going to have to do server-side rendering. The other thing with this is just for SEO. We need to be able to show our search result pages to browsers or bots that aren't running JavaScript. And so the closure templates made a lot of sense. But then we also wanted to throw Instant on top of it. We wanted you to be able to quickly get feedback. If you did have a capable browser, and we wanted you to be able to work very quickly. We wanted you to be able to kind of browse the search results, rather than doing a search, waiting for results, and having the page reload. So this one template for the results is actually the same one that we end up using in Java on the back end. Here's just a quick example of rendering that template. But then we get to do the exact same thing on the client side. And so you can see this kind of the same namespaces here. And that's again where the namespaces come into play, especially when it relates to closure templates. And so with this, on the server side, we're able to take just those query parameters and render it out in soy. But then if we see you come in with an AJAX request, if you're coming in with a request, we'll go ahead and we'll skip the actual rendering step and just redirect the output to JSON. So we actually, on the server side, aren't doing any extra logic. You're coming in with the same query string, even when you're working with Instant. You'll notice after the hash bang, is just a query string itself. And so all Instant is doing is sending that same query string back to the controller. And all we care about is we build the exact same model in both paths. Just at the very end, we decide to render it either as HTML or we render it out as JSON. And so this has allowed us to continue to build resume search without having to worry about writing our templates twice, or worrying about or having trouble with like choosing one or the other. So Twitter actually released a post about this. Now I guess it was a few months ago, talking about kind of what some of their issues that they were having with performance. And so with Twitter, they always use the URL fragment. And they noticed though that when you would come to Twitter, you had to load the homepage first. You have to go through the whole cycle to load the homepage. Because until they actually send a response back and they have enough JavaScript to execute, they don't actually know what's after the URL fragment. So what they're starting to switch to is they're doing now server-side rendering. You'll notice now canonical URLs are full URLs that are going to be rendered by the server. And so their choice to kind of go client-side only started to affect them with this, and they started to notice it empirically with the speed of their responses. And so with the templates, this was something that we kind of got for free. And it's been really helpful for us in that we can use canonical URLs that are just standard query strings. But then once we turn Instant on, we can use the URL fragment that then is also just doing a query string. And so you can just change that hash bang to a question mark, and the search will be the exact same search that you had just seen. And we're working on making this even a bit better. We did this all with URL fragments, just like Twitter did. But what we want to move to is more the HTML5 push state for history. So we can actually change the URL. So that as far as the user is concerned, they won't be able to tell the difference whether they're on the client or on the server. It's going to be the exact same URL. And both URLs are going to work with very little maintenance on our side. So the main motivation behind all of the way that we built resume search was to keep it very event-driven. And as a result, we were able to make it so that we had very independent components. And so this has helped us with maintainability, and we can continue to move very quick in improving the UI for resume search. We also got away with writing this once, and this had pretty large effects on us. We were able to keep up a very high-speed web application, be able to handle SEO, while still providing a very good user experience for those that were just trying to use the site. So let's go back to that initial application that we were writing, that $1 billion photo sharing app. And we ended up at 45K. And so that was before we had actually written any application code. This is just jQuery, a couple of those plugins, and the date and validation library. Well, I went ahead and ran the resume search code through a couple of the different modes on the compiler. And so you can see with whitespace only, it's a pretty large file, and even with simple optimizations, it's still at 90K, which is pretty large. But when you do the very aggressive renaming, and you get rid of all the dead code that you don't actually end up using, we end up with a 41K file. And this includes all of our templates, this includes all of our logic, and any of the library functions that we end up using. So I believe jQuery is actually at 41K. So we have, our whole application is the size of the jQuery library. So given this, once we figured out kind of how nice this has been for resume, we didn't want to just keep it on the resume team. We wanted to kind of spread it to some of the other teams at Indeed. And so we looked at job search. So job search is now coming up on being an 8-year-old project. And as a result, it has 8 years worth of JavaScript. And we wanted to see what we could do with it. And so what we were starting with was a single monolithic file. It's actually called job search all. And it had everything in it. And it was all hand optimized over these 8 years. And the reason we did the hand optimizations was that we wanted it to be very fast. I mean, just like with resume search, with job search, it's even more important that we're serving extremely fast pages. So we needed this file to be very small. So over 8 years, we've been hand optimizing, we've been avoiding any libraries. We've been doing tricks like we have an alias of GBID for document.getElement by ID, just in case the renaming wasn't going to help us. We also had to re-implement a lot of things that you would find in libraries because we needed things like class manipulation, style manipulation, and cross-browser events. We also took some kind of shortcuts when we were doing AJAX requests, just because we didn't want to bring in large libraries to help us do these things, because we needed the small file size. Well, so we spent a few days converting job search all into Clojure. And the way we did that was we just went section by section and broke it into modules. So we broke it into small files, added the provides and all the requires. But we didn't actually change any of it either. The goal for this first run was just to split it up into modules and then migrate over our unit tests. So we would make sure that we didn't actually break anything, since a few million people see, indeed, we didn't want it breaking for a lot of people suddenly. And so what we found out though is once we ended up doing this, we actually decreased the size of the job search file by increasing the amount of text that we were using. So we were using the Indeed, that job search, and all those long namespaces, but we didn't actually change anything else. We had all this hand-optimized code, and we were trying to keep it as small as possible, but we actually didn't do any better, and we did quite a bit worse. I think this is a 15% improvement. And so we've been expanding this now because we've seen just how big of a deal this has really been for us. And because now with job search, it's a much more maintainable file. We don't have to be afraid of touching that. We have really nice unit tests. We can actually run them in our continuous integration environment. So we're constantly running our tests and treating it as if it was a real application, where it's not just a fun front-end web app anymore. Not that it ever was. But this has been kind of what we have found with the Clojure library in general, is that it's really helped us solve a lot of these problems that we weren't able to do previously. So we can now do a lot of front-end work with the templates, but still get all the benefits of server-side rendering. We can now use library functions without having to worry about really bloating our code. We don't have to worry about using a large library because, as we've seen, the code actually ends up, the compiler does a much better job than we could ever do in optimizing. And so with that, I'll start with any questions.